Hello everyone. Here I am going to discuss about the topic in measurement system, that is static and dynamic characteristics. So why we need to find the static and dynamic characteristics? So during measurement process, the sensor must be able to sense the measured value and convert it into the corresponding electrical signal, that is current or voltage, without any distortion. So the indicator for measuring the sensor is mainly its static and dynamic characteristics. Means knowing the static and dynamic characteristics of the sensor is very helpful in selecting the sensor. So because of this you can know whether this sensor is suitable for that particular application or any occasion or not. So first, static characteristics. So what is the static characteristics? It is the set of criteria defined for the instrument which are used to measure the quantities which are slowly varying with time or mostly constant. Means these characteristics of the system measure when the input is either held constant or varying very slowly. So there are various static characteristics, that is range, span, accuracy, precision, then sensitivity, linearity, threshold, resolution, repeatability, reproducibility, noise, hysteresis, like this. So we will see one by one. First is the range. So range is the minimum and maximum value of the physical variable that sensor can sense or measure. For example, RTD, that is resistance temperature detector, which is a temperature sensor. So its range is minus 200 degree centigrade to 800 degree centigrade. This is a range. Now span is the arithmetic difference between upper and lower range values. So as I told you, RTD, that is resistance temperature detector, which works over the range of minus 200 degree centigrade to plus 800 degree centigrade. That's why this span of RTD is maximum value, that is 800, minus of minimum value, that is minus 200. So span is nothing but the 1000 degree centigrade. Now sensitivity is the ratio of change in the output to change in input under static or steady state condition. So here in first graph we can see there is a linear relationship between the input and output, and in second graph there is a non-linear relationship between the input output. So in first graph, linear relationship between input and output, that's why the sensitivity is equal to the slope of calibration graph and is the constant. Okay, and in second one, sensitivity will vary according to the value of output, because this change in output and change in input, this graph is non-linear. That's why this sensitivity changes according to the output value. So I have added on this formula for measuring the finding the sensitivity. So now linearity, it is the ratio of maximum deviation between the actual characteristics curve and the fitting straight line in the full range to the output value of full range. Means it refers to degree to which the actual relationship curve between the sensor output and input deviates from the fitting line. So we have to add the one line, that is linear line. So with the help of this we can calculate the linearity. So the to find the linearity is the formula for that is delta O divided by change in the output, that is O maximum to O minimum, where the delta O is the difference between the maximum deviation from that the graph to this fitting line. Now resolution. So resolution is the smallest increment in measured value that can be detected when certainty by the instrument. That means when the some input is slowly increased from some arbitrary input value which is non-zero, the output doesn't change at all until a certain increment exceeded, and this increment is nothing but the resolution. Now the threshold. Threshold is the minimum value of the input below which no output can be detected. So there is a small difference between this resolution and threshold. That is, here this in threshold defines the smallest measurable input, while the resolution is the smallest measurable input change. Now hysteresis. So the definition of hysteresis is the maximum difference into the reading for the same input when approached from opposite direction. That is, when increasing and decreasing the input. So here is we can see the graph. So from this here in this graph there is a forward direction and reverse direction. So for example, let me give one example. If we are giving some input value, that is x1, so we are getting corresponding output value y1. So as input changes, increases, x1, x2, x3, x4, that is up to xn, then we are getting corresponding output, that is y1, y2 up to yn. After that, while reversing, when we are giving the output value, that is xn, we are getting output value yn. When we are decreasing from xn minus 1, input value xn minus 1, xn minus 2, xn minus 3, that time we are not getting the output value, that is yn minus 1, yn minus 2, yn minus 3. We are getting different output, and this difference between this reverse and forward direction, so this is called as a difference, and this difference is called as a hysteresis. So we can find the hysteresis is the h, that is the difference between these two values divided by change in the output into 100. Now accuracy is the accuracy is measured in terms of the error. So error is nothing but the measured value minus true value. So it is the closeness of the instrument output to the true value of measured quantity. Now precision. So the highly precise instrument is one that gives the same output information for the given input when the reading is repeated large number of times. So what is the difference between precision and accuracy? These two concepts are very different. So from this diagram we can see that there are small cross marks in blue color, and a center point, there is a center point which is in orange color. So let me give one example. For example, let xt be the true value of variable x, and random experiment measure x1, x2, x3 up to xi. So as value of x, that is, so x1, x2 up to xi are the precise when, so x1, x2, xi, these are precise when they are near to each other, but not necessarily they are close to true value of xt. But if they are close to true value of xt, then they are accurate. So in first diagram, these all cross marks, that is x1, x2, x3, they are very close to each other, near to each other, and also they are close to the true value of xt, that is orange, which is shown in orange color. So here this is high accuracy and high precision. In second diagram, these x1, x2, these variables are close to each other, but they are away from the true value of xt, that is in from this center. So because of this is a low accuracy, this is away from the true value, that's why this low accuracy and high precision. In third one, they are close to the true value as compared to the second one, but they are away from the each other, that's why high accuracy and low precision. But in fourth diagram, they are not close to the each other, and they are away from the true value, that's why low accuracy and low precision. I hope you understood the difference between precision and accuracy. Okay, means the equipment which is precise is not necessary this should be the accurate. Now repeatability. Repeatability is the ability of instrument to display the same reading when a constant input is applied repeatedly at short interval of time under fixed condition. Now reproducibility is the ability of instrument to produce the same output when the same input is applied. This is for short interval, and this is reproducibility is for the long interval. Even means this gives same output when we applied same input, even taken over long time interval, also for performed by different operators with different instrument, and even in different laboratories. So now dynamic characteristics. So it is the set of criteria defined for the instrument which are changes rapidly with time is called as dynamic. Static is the constant, measure the constant, and here dynamic is the changes rapidly with time. So these characteristics of the sensor tell us how fast transducer responds to change in the input. So dynamic characteristics are determined by analyzing the response of sensor to family of variable input waveform. For example, step input, impulse input. So there is a diagram, we can see that step input, impulse input waveforms. So the dynamic characteristics are speed of response, then lag, dynamic error, also transfer function is also dynamic characteristics. So speed of response, it is defined as the rapidity with which measurement system respond to change in the measured quantity. Okay, then second one is the lag. Lag is the time to respond to the particular instrument when we change the input. Means there are two types, retardation lag and time delay lag. So in retardation lag, when we change the measured quantity, the instrument also changes its value in faster way. But in time delay lag, it instrument changes its value after some time, even when the measured quantity changes. So retardation is the faster way, it gives output in faster way, and it delay means it required time. So thank you. I hope you understand the basic concept. So do not forget to like, share, and comment, and not do not forget to subscribe to my channel. Thank you.